Okay. So basically, today we are going to discuss what this course is about and what kind of topics are covered as part of this course. Okay. And then little bit introduction about Snowflake. Okay. You're able to see my screen?
Yes.
Okay. So this course is about completely about data engineering, guys. So we are going to use different set of tools like Snowflake, AWS, DBT, AirFlow, and a little bit of Python. Okay. So generally, what is data engineering? So if I ask you what is data engineering, so can anyone answer like what is data engineering? Anyone have any idea before if you have worked on databases or something? No. Okay. So I will tell you like what is this particular data engineering is. So for example, uh, I'm going to like order a book from Amazon or order some product from Amazon, right? So you are going to get some recommendation like buy this product and this together, you'll get some discount, right? So how you're going to get that discount? So what is happening in the background, right? So let us try to understand that first. Then you'll understand why we do all this data engineering stuff. Okay. So you might have seen this recommendations, right? So when you order a product, they'll be suggesting some things together, like this product and this product together, you'll get a discount. Okay, indirectly they are improving their business, right? So how this is happening here? So I will explain you with the diagram first, then we'll go there. Okay. Okay. So generally what happens in the background, let's take the Amazon use case or any other business for that matter, not only Amazon. So what they do is they will be storing your current data in some databases called OLTP databases. Okay. So what is an OLTP database? It's online transaction processing database, OLTP. Okay. So what these particular databases are going to do? Okay. So these particular databases are going to store your current data here. Okay. So when I say current data, maybe last 1 year or 1.5 year data. Okay. So what are the products that you bought or what are the products inventory available currently, right? Who are the sellers, right? So all those things are stored here in these databases, OLTP databases. Okay. Now, these databases are designed for handling small volumes of data. Okay. So it cannot handle very huge volumes of data and you cannot do some queries on these particular databases. Okay. So these particular databases are designed for small volumes of data, but the response is really faster. So these are transaction systems. So the response is really faster within seconds. Okay. So you can write or you can update, you can read the data with small volume only. Okay. And as the data is getting older here, okay, so let's say you're using Amazon for the last 10 years, okay, so it's not going to store all your 10 years history here, okay. So for that, it is going to move that particular historical data into a different systems, okay. So these are called OLAP systems, online analytical processing systems, okay. And these systems are designed for holding huge volumes of data, and you can even get the results really faster when you are reading the data. Okay, reading is really faster on these particular systems here on huge volumes of data, terabytes and petabytes of data here. Okay, so all your current data will be there in your OLTP system, and all the historical data, all the old data that will be in your OLAP system. Okay, now, why I need all this historical data, old data, right? So there are two purposes. Okay. So one is generally you may generate some reports, some analytical reports on your historical data. Okay. Right. So someone will be using some tools to render your data in the pictorial format. Maybe I want to generate the sales of a particular company in a bar chart or pie chart and show it to my management. so that they'll get a clear understanding like in which quarter our sales are high, in which quarter our sales are low. So all this stuff you can do on the historical data that we move to OLAP system, right? The other stuff is I wanted to apply some algorithm for predicting something. Okay, so for example, you might have heard about data science or okay. So what is data science here? So you are going to use this particular historical data, apply some algorithm and do some predictions. Okay. Like some sales, right? Some sale predictions you can do through data science here. So in case of Amazon, how you are getting that recommendation. So this particular product and this particular product, you want to buy it together. So how you are getting that recommendation. So there is a person who is sitting as a data scientist here who is going to use this historical data and he is going to use that data and get some recommendations from that. Okay. And the person who is doing this particular reports are called, you can say data analyst here. Okay. So he is a data analyst here who is generating some static reporting on your data. Right? So analyst generates the report, scientist will use the, oh, I mean, all the historical data. He is going to generate some predictions or he is going to recommendations, right? So all the stuff he is going to do it, right? Then who are going to maintain moving the data from OLTP system to OLAP system, right? So I need to move the data as it is getting older. I need to move the data into OLTP to OLAP system. Okay. And the data that we are getting from the source system is called raw data. Okay. Raw data. And this raw data is not directly consumable. We need to perform some filtration. Okay. And after doing the filtration or some other transformation, we call it as, we store it in a format called curated data. Okay, or transformed data or modeled data. So we call it with different names here. So this particular curated data is going to be used by your reporting team or your data science team. Okay, sometimes data science team also access raw data directly, and they also access some curated data here. Okay, now who is responsible for building this particular process or this particular flow, right? So this is called data pipeline, guys. Okay, so from source system you have to extract the data. That means get the data, right? And load it here into your data warehouse. Sorry, in the OLAP system, we call it as data warehouse also. And then you need to transform the data. Okay. So you also need to transform the data. So for example, I am getting the sales data here into the raw layer. Now I wanted to aggregate the sales at month level, year level, quarter level, right? So those kind of transformation I wanted to do. So that is your curated data. Okay. So it is similar to like your raw water. So you get the water from rain from different sources. Okay. And you are going to purify that water and use it for agriculture purpose, use it for drinking water purpose, right? So similar way, the data pipeline works in a similar way. So you will be getting the data from the source system and it will be stored as the raw data and you're going to transform it and you're going to share the curated data with all the downstream applications. Okay, so here in maybe in one case your source can be only database. Okay, in some cases it can be some application directly. Okay, some web application, or you might get the data from some sensors. You may need to get the data from sensors, or you may need to get the data from some file servers. Simply some files are placed here, right? So all these sources data will be combined together and loaded into your OLAP system and used it for further analysis. Okay, so who are going to build this data pipeline? Who are going to maintain this data pipeline? Right, this extraction, loading, and transform. So this is where data engineer comes into picture, guys. Okay, so the data engineer work is to build this pipeline, to design this pipeline, and to maintain this pipeline. Okay, right. So this is what a data engineer does. Data engineer. right? So here the data engineer sits, and this particular data used by your data analyst and data scientist here. Okay. Is this clear, guys, or you have any question here? Maybe some of you know this process already, but I wanted to just reiterate. Okay, so if this is clear, so now let us try to understand what are the tools needed for a data engineer, or what are the technologies that you need to know as a data engineer here. Okay, so the first thing is, if you're working with some OLAP systems, okay, so it will be Snowflake. Okay, Snowflake is my OLAP system, or we call it as, you can also say it as data warehouse or OLAP system, right? And this particular system generally will run on the cloud nowadays. Okay, so you don't use your own servers. Okay, so it is going to run on the servers, sorry, on the cloud, right? So you may need to know some basics about your cloud. Okay, so in this particular cloud area, you may know, you may write AWS or Azure or GCP, Google Cloud Platform. Okay, so these are the main technologies or main vendors of the cloud in the market. Okay, so in the market for data warehouse, there is Snowflake, there is BigQuery, there is Redshift also. So there are a lot of lists for data warehouse. BigQuery is from Google, Redshift is from Amazon, right? Synapse is there from Microsoft, and Teradata is there, SAP HANA is there. So there are so many tools in the market. Okay, but we'll see why Snowflake is different from all these things. Okay, and the when it comes to cloud, it can be any cloud, AWS or Azure or GCP. So as a data engineer, you need to know the basics of this as well. Okay, and to do this extraction and loading, okay, and transformation, you may need to know some ETL tools. So you might have heard about ETL tools in the market. So most of the famous ETL tools are like Informatica, and Azure Data Factory, Matillion, right? So the list is really big here. Okay. And apart from this, you need to know about a little bit of scripting in Python. Okay. So to do some automations. Okay. And also you may need to work on some scheduling tools. So you need to run these jobs daily, right? So something like AirFlow or Autosys, right? So these are the tools that you may need to know to enter into the data engineering market. Okay, so before all these guys, you need to know SQL. That is a prerequisite. Okay, you need to know the SQL. So how to write the queries to interact with your database. Okay, so this is like the prerequisite, and all these things, okay, I am going to teach in the course here. Okay, so we are going to choose Snowflake as our data warehouse, AWS as our cloud, and in this particular ETL tools area, I'm going to use DBT. This is one of the new tool, data build tool. Okay, and we are going to discuss about some of the Python basics, and I'm going to show you how the Airflow is used as a scheduling tool here. Okay, so this is complete stack, guys. So it's not only about Snowflake, it's about all the tools that we use in the data engineering. Okay, so when I say all the tools, like specific tools I have picked which are there in the market currently. Okay, right? So if you wanted to know like how the data engineer their job description looks like, so you can go and say data engineer, right? So if you wanted to see some job description, so it looks like this. So they are asking about your Python basics. Okay. So they are asking about the AWS basics, and they're asking about the SQL, right? So, and some of the very basic version control tools, CI/CD tools like GitHub, etc., and Snowflake also. Okay. Let us go to some other. Okay, so here see they're asking about fluency with Airflow and DBT and Snowflake or BigQuery, right? And they're also asking about Python here, right? So all these technologies are required to build your data engineer career. So if someone says, look, just learn Snowflake and then try to enter into the job market, it is a little bit difficult. Okay, so you'll get very less opportunities. Okay, so that is the reason like I designed the course to cover almost all this tech stack here. So if you see my course content here, so we are going to discuss majority of our sessions are on Snowflake, around 20 sessions, 20 to 25 sessions on Snowflake. So we are going to see Snowflake topics like introduction, administration part, how to load the data into Snowflake, how to build the data pipeline, right? And what are the Snowflake special features. So the first 5 modules are about Snowflake. Then we'll see how to integrate Python with Snowflake, how AWS can be integrated with Snowflake, how DBT tool can be integrated with Snowflake, and how Airflow can be integrated with Snowflake. Okay, so these are the topics that I'm going to cover as part of this course phase. Okay, so anyone have any questions here? Okay, so you can ask questions. Don't hesitate if even it is like don't think it is some silly question or something. Okay, so clear with this guys? Are the about the course content or any questions? Okay. Yeah. So if you're clear, then just we'll discuss something basics about Snowflake today, like very basic about Snowflake, like how to create the trial account and what is the architecture of Snowflake. Then we are going to continue the regular sessions later. Okay. So if you go back to this diagram where Snowflake fits is Snowflake is a analytical processing system or a data warehouse. So this is my Snowflake. Okay. Okay. So now this particular Snowflake is a data warehouse and it's a cloud data warehouse. So it can run on any of your major clouds, okay, like AWS or Google Cloud or your Azure, okay. So this particular Snowflake, you cannot install it on your machine directly. So it has to run in one of the cloud services, okay. So it's a cloud data warehouse, right? So everything is maintained in the cloud. You don't need to install the software. You don't need to update the software. Okay, all the patching, everything will be taken care. Okay, so that is the beauty of the cloud. Okay, you don't need to install on your machine. So now let us try to see how to create a Snowflake account quickly on the cloud. Okay, so first we are going to see how to create the cloud, and then we are going to see what is the architecture of Snowflake. Okay. So first of all, if you want to create the Snowflake on the cloud, simply you type Snowflake trial. Okay. So Snowflake is offering a 30-day free trial account. So you can use it for 30 days here. And once it is expired, also you can create a new account again. Right. So this is the page that you'll open here and you need to fill all your details here. Okay. Right. So any like all your details you need to fill here. Right? And then here, if you see there are Snowflake editions. Okay, so there is a standard edition, enterprise edition, business critical edition. Okay, so each edition has some features. So standard is like very basic edition. You have some features, and enterprise is standard plus some extra features. Business critical is enterprise plus some extra features. Okay, so for us, enterprise is enough to discuss about these topics. Okay, all the topics are covered in the enterprise edition only. Okay, so even if you can choose business critical, not a problem, but don't choose standard. Standard does not have all the features. Okay, so now I have chosen this particular edition. Okay, so this edition is like you're going to buy a car, and there are different variants, right? So I wanted to take this power windows, or I want to have something else. So depending on the edition, the features will vary. So similar way, here the editions, depending on the edition, the features will vary for Snowflake. Okay, and once you choose the edition here, you need to choose on which cloud you want to run your Snowflake. So I told you Snowflake is a cloud data warehouse, right? So it's going to store your historical data, but it is going to run on your cloud. Okay. So which cloud you want to use? You want to use Microsoft Azure or Amazon Web Services or Google Cloud Platform. You can choose anyone here. Okay. So I'm choosing AWS here. Okay. And just click on this particular checkbox. Get started. They are going to ask some survey questions here. Just skip them, right? So you will be receiving an email. Okay, you'll be receiving an email. Then you need to activate your account here. Okay, so just open your email ID. You should be receiving an email from Snowflake to activate your account. It's not received yet, but just I'm checking. It went to some other folder. Generally, it won't take much time. Within a minute, you should get it. Okay, so let's wait until we get this message. But anyway, I have already created one Snowflake account. I will show you like how to log into that account. So I have already created one account. So you're going to receive an email like this. Welcome to Snowflake, something like this. Okay. Then you need to set up your username and password initially. I will show you once I receive the email here. So just I will log in and show you how the Snowflake UI looks like. Okay. I have already set up my username and password for this. Okay. So this is called Snow Site, guys. Okay. The user interface of Snowflake is called Snow Site here. Okay. Now, if you want to run some queries on top of this particular Snowflake, you need to open something called worksheet. Okay. So here in the projects, you'll see worksheets here. Okay. Worksheets is the place where you write your code. Okay. So simply click on this plus symbol. It's going to create a worksheet for you. Okay. And now simply I'm going to run some query like select current timestamp. Just wanted to know what is the current timestamp. Then you press on this particular play symbol. It's going to show you the result here. And in the right hand side, you'll get a statistics also. For example, I'm trying to run a query from a particular table. So this table I have already created. We are going to see this later, but just I wanted to show you how to query a table here. right? So this is how you'll see the results here. Okay, and in the right hand side, you are going to see the query statistics, how much time the query has taken, total rows, right? And you find some each column level statistics also in the right hand side here. Okay, see, so this is how you can query the data from Snowflake using a worksheet here. Okay, so you need to create the Snowflake account and then you need to activate it actually. So yeah, I have received it. See, so let me just activate this particular account. Just you need to click on activate. So provide your initial username that you wanted to use and the password. Okay, so initially it looks like this. It is going to give you some tour, but we can skip it. See, this is my snow site. Okay, so now I wanted to open a worksheet. So go to projects, worksheet, click on this plus symbol. You're going to see the worksheet here. Okay, so this is where you can run your queries simply. Okay, clear guys? How to create a Snowflake account, the trial account, and how to run the queries. Or any questions you have? Okay. So if this is clear, let us try to understand what is Snowflake architecture. Okay, right? So now we are going to see how Snowflake is designed internally. Okay. So first of all, this Snowflake has three layers. Okay. So these are the three layers of Snowflake, and the first layer is called cloud services layer. Okay. So the first layer is called cloud services layer, and it is also called brain of Snowflake, right? So what does this cloud services layer mean, right? So for example, when I'm writing a query on Snowflake, right? So I'm going to write a query here again, maybe some sample data, some customer data. I'm going to query here. Select, right? So what will happen is this query is going to hit the cloud services layer first. So it is going to hit this particular cloud services layer. Okay. So what will happen in this particular cloud services layer? So it's going to check the syntax. Okay. So whether you're writing the query as per the grammar rules. Okay. For example, I'm missing from class here. So it has to throw an error, right? So there is a problem with this particular query here. Okay, so it is going to check the syntax. If your syntax is good, it is going to check whether your tables are existing in your database. So for example, instead of customer, I gave customer 100. So this table is not existing in your database. So it's going to throw an error, right? So it is going to check whether you have access to the tables or whether this table is already available in Snowflake or not. Okay, so this particular thing also checked in your cloud services layer. Then the next thing is it is going to check the optimizer plan. Okay, so each database, you take any database, so it will have a optimizer. Okay, so what does optimizer do in a database? Anyone have any idea? Okay, so in order to get the data, right, from Snowflake or from any database, you have different paths. Okay, so for example, I am reading a book. Okay, so let's say I'm in between chapter 10 and again I stopped reading the book. I came back and resumed reading the book, right? So what I do, so either again to go to chapter 10, I may go page by page, okay, or I will take the index page and I'll see which page number chapter 10 is there and I will jump directly there. Okay, so which one is faster? So mostly going by the index is faster, right? So this optimizer is going to generate different paths to access your data. Okay, so in which way, whether it is full table scan or whether it is a partition scan or whether it is index scan. So it is going to evaluate all the paths to get the data really faster. So to get this data from customer table, there are multiple paths. Okay, so this optimizer is going to generate all the plans and it is going to give you the best plan. Okay, so that is what your optimizer does. Okay, so once your syntax is checked and once the tables are existing, so it's going to generate the optimizer plan. Okay, so this is about cloud services layer, and this cloud services layer also responsible for some other things like security and metadata management, etc. Okay, so what is metadata, guys? Anyone have any idea? What is metadata? Okay, so metadata is generally the formal definition is data about data. Okay, so what does this mean? Right, so when you create a table inside Snowflake, let's say I have created these many tables. So for each table, the information is stored in another table again. Okay, so what are the tables that we have created and what are the columns in that particular table? What are the data types of the table? What are the sizes of the table? What are the constraints on the table? Right? Everything is stored inside the database. So that is called metadata. So that metadata has a lot of applications. Okay. So when you create the table, so it's going to store all the data about your table. So not only table, if you create some other view or any object in your database, it's going to store that data. So that is called your metadata. Okay. So the metadata management is also responsibility of your cloud services layer. Metadata optimization, security checks, transaction processing, and database management. Okay, so this is the first layer that is going to, uh, when you submit a query, it is going to this particular cloud services layer first. Okay, so once the optimizer plan is generated, then the second layer. So what is this layer is compute layer here. Okay, the second layer is called compute layer. So now you need to bring the data from your storage, right? But for that you need to do some computation. Maybe I wanted to join two tables or I wanted to do an aggregation, right? So all those things are done in your compute layer. So in order to run your query, your compute layer will use something called virtual warehouse. Virtual warehouse. So what is this virtual warehouse? It is a server which executes your query. Okay, all the computation part it is going to do. Okay, so the beauty with Snowflake is these virtual warehouses comes in t-shirt sizes. Okay, so if you see my Snowflake screen here, in the right hand side, in this particular drop down, what you are seeing is this is your virtual warehouse. Compute underscore WH is my virtual warehouse. Okay, so to run the query, you need some computation power. You need some server in the background, right? So that server is this. And it comes with different sizes. Like currently it is extra small size. Okay, so when I say extra small size, maybe it will be having 1 GB RAM. Okay, but let's say 1 GB RAM is not enough for processing my query. So I wanted to increase the size of this particular server or virtual warehouse. Simply I can do it here. So instead of extra small, I'm going to use small here. Okay, so now I changed the size of the virtual warehouse. So this query may run faster when compared to extra small virtual warehouse. Okay, because it has more memory, more computation, more CPU to compute your data, right? So that is the reason you can resize your virtual warehouse here. So it comes in the t-shirt sizes here. Okay, but at the same time, when you're going for a bigger warehouse, you need to pay more number of dollars to Snowflake, right? Because you're using more resources, so you need to pay more dollars, right? So that's the reason. So you should be really careful while changing the size of the warehouse, whether it is really required or not. Okay. So this warehouse is like your computation power. Okay. So I wanted to join the table. I wanted to aggregate some data. So everything done in this particular computation layer. Okay. And the third layer in Snowflake is your storage layer. So this is like your hard disk. The storage layer is like your hard disk in the computer. Okay, so this is where the data is stored, okay, in the form of partitions here. Okay, so the third layer is called storage layer, and the data is stored in the form of micro partitions. So this is like your hard disk, and this is like compute layer is your like your CPU. Okay, so now how the data is stored in the form of micro partitions, I'm going to show you. Okay, so but before that, what is the advantage of storing your data in the partitions? Why we use partitioning? Any idea? So partitioning is like storing your data in different chunks or different places, not in one place. So what is the advantage of it? Yeah. So performance is the reason that we do the partitioning. Okay. So I will give you a simple example. For example, I asked you to go to a school and find class 10 student. Okay. Class 10 student with the name XYZ. Okay. So what you are going to do, if the students are sitting in their own classrooms, like class 1 to class 10, you directly go to class 10 and find that student. Okay. You're going to ask who is XYZ and you'll get that student. But let's say all the students are sitting in an auditorium. Okay, so then if you want to find the student XYZ with class 10, so how you are going to do? So you need to go to each and every student and ask like, are you from class 10? Are you XYZ, right? These two questions you need to ask and repeat for all the students until you find that particular student, right? So partition also works in similar way. So when I'm running my query, like let's say my query is like this, select star from my table name, where year in 2001. Okay, so for example, I have 10 years of data from 2001 to 2010. Okay, and each year is having 1 million. That means 10 millions of data I have, but I am searching for only 1 million of data, right? So if you store your data in partitions, like the first partition, the 2001 in first partition, and the 2002 in second partition, right? Like this, like this, if you're going to store the data in 10 partition, so I will know my data is there in only partition 1, so I'm going to scan only this particular partition. I'm going to eliminate all the other 9 partitions here. Okay, so that is the advantage of partitioning here. Okay, so this partitioning technique is there with other databases also, but Snowflake has a special feature called micro partition. Okay, so we'll see what is micro partition and how the data is stored. Okay, in the upcoming sessions. But this is how generally your data is stored here. See, your table is having 24 rows here, and each 24 rows are divided into just 6 rows in each partition. So the first partition stores 6 rows, the second partition stores 6 rows, the third partition next 6, and fourth partition stores next 6 rows. So this is how the partitions are organized generally. This is just for understanding. Okay, so there are total 24 rows and they are divided into 4 micro partitions here. Okay, so this is how your data is stored in the form of micro partitions inside the storage layer. Okay, so clear guys with the architecture. Basically, it will have 3 layers: cloud services layer, compute layer, and storage layer here. Okay. Clear with this, or you have any questions? Okay. So I'm not going to overload you in the first demo itself. So we are going to see all these topics that I have listed here. So all these topics like we'll see the administration part and how to load the data, right? So for the first 5 modules, it will be around 20 to 25 sessions. We are going to discuss on Snowflake, and the other sessions are on basics of Python, AWS Cloud, DBT, and AirFlow. Okay. So I'm going to regularly continue the sessions from Monday onwards. So the session timings will be around 7, same thing, like 7 a.m. to 8 a.m. days. Okay. And I have created the WhatsApp group for all the people. So if you wanted to be added in that WhatsApp group, I'm sharing my number. Just ping me in this particular number. Okay, so this is my number. Just ping me on this number. I'm going to add you to the WhatsApp group. So let us stop the session today. Let's meet on Monday to continue on the other parts. Okay, thank you.
Thank you, Vinay.